Jeez. Okay. I thought I hit the record button, but okay. Well, keep recording this. All right. So we've went over the floating point numbers. We went over these operations over here. Now it follows. Now, as far as doing things like this, more complicated expressions, as we call them, not equations, but expressions, because you evaluate these expressions. 3 times. Let's see. Let's keep the math simple, right? 1 plus 3 times 2, right? This should give you like social media flashbacks here, right? Of like, 99% of people can't do this equation. No, it's a lot of those operate off of ambiguity. Type it into a computer, and you'll get most likely the right answer. So over here, right, you should have learned, hopefully from middle school, what to do, which is PEMDAS or BEMDAS, depending on whether or not you're from the Commonwealth or your education is from the Commonwealth. So here you have 3 times 2, which is 6, plus 1, so our answer would be 7, because you do your multiplications before you do your addition operations. Exactly the same. So all these rules are exactly the same as you would do in any math course. Exactly the same. You'll be tested on them, but you already know it. Okay? For instance, if I were to do 1 plus 3 times 2, that changes my answer, right? Parentheses, next is exponentiation, right? Parentheses, so you can use parentheses for your expressions. Next is exponentiation. This is the only, now I like what Python does for exponentiation. Most programming languages, exponentiation, 8 squared, it would look like this, but not Python. That gives you 10, of course. That gives you 10. This is because the caret operator is already reserved for a completely different operation, one that you do not have to worry about until you're in operating systems or some other class like that. This is a binary operation, the XOR exclusive OR. You can completely forget that knowledge now. Instead, the way Python does exponentiation is that you use 2 stars rather than 1. 2 stars, right? 8 squared, 8 cubed, 8 to the 10th power. It does it quickly. By the way, Python doesn't really care. So other programming languages, if you're working from another programming language, it cares about how big the numbers are, right? Integers in other programming languages like C or Java, they're 32-bit numbers, meaning they only go up to about 2 billion on one hand and negative 2 billion on the other hand, right? Or they're longs, in which case they're 64-bit numbers and ginormous, okay? But Python doesn't care. It says, oh, you need more digits? That's fine. I don't care. And Python will do it. Python will do it quickly because computers are good at math. Okay? So that's how exponentiation works, right? It is, and it makes sense because like exponentiation is just repeated multiplication. So, okay. So the next operator is, so we had PE, and then we had PE, and then we had MD, multiplication and division, which is the good time to talk about this other operator here, the modulo operation. Right? 85. So we have a grand total of 1, not 1, not 2, not 3, but 4 different multiplication operation divisions. Well, technically 1 multiplication and 3 division operations. Okay? So first, 5 times 10, we know that one, right? Multiplication, we already know. Next up, we have 2 divisions, depending on what we want to do. Okay, first is your standard expected no surprises division. Okay, so here let's do 11 divided by 2. That gives us 5.5, right? This is our standard expected division. The other division operation is what we call integer division, which, right, here I'm dividing an int, I'm taking an int, dividing it by an int, and then getting out a float. Sometimes this is undesirable, okay? Sometimes it's undesirable. When would this be undesirable? Wait a minute, I'll show you, okay? So here, if I do divide 2, you get 5. Basically, it just throws out anything after that decimal point. Now, why would I want to do this? Sometimes I just care about the quotient, right? If you remember all the way back to like elementary school when you first learned division, they did that whole symbol, they did that whole thing with the long division symbol, and then you had the quotient of the remainder. Well, you're about to get some flashbacks from that. So you use this to get the quotient of that long division, okay? So, for instance, if I were to do 100 divide 3, it gives me 33, right? Because 3 can go wholly into 133 times. There's a bit left over, right? There's a bit left over, but we don't care about that bit left over right now when we do this. It says, I want an integer. This is typically useful if you want to do something when we want to manipulate numbers. What do I mean by that? Like, say I have a number like this. It can be whatever I need, right? But I can do something like this, divide 10. And what that does for me is that I never look at this as like dividing by 10. I look at this as throw out the right digit, the rightmost digit. See what I mean? It just throws out that rightmost digit. So that's kind of a context where you might want it. Okay? So let's go back to our 11 divide by 2 example, because that math is nice and easy. 11 divided by 2 is 5.5. 11 integer division 2 is 5. So now we have our third operation, which is modulo, which we use the percentage sign for. Okay? Now modulo has this whole complicated math thing behind it that I think I learned in like group theory or possible other, or maybe computer science, concepts of computer science math classes, a bit in modern algebra. You don't need to know any of that. What you need to know, all you need to know is, well, this gives me a float. Integer division gives me the quotient. What's the thing that's missing? What's the bit that I haven't solved for yet? Yeah?
Remainder?
The remainder, right. What this does, it gives me the remainder. That's all modulo does. So it's a funny symbol, but all it does is give you the remainder. So, in this context, right, this throughout the last digit. This throws out everything but the last digit. Super easy. On your exam, you'll most likely have a question like this, where I will tell you, no calculators, please solve this. Right? What's the remainder after dividing by 10? 3, because it's the only thing left over. 10 can divide all this stuff, but it can't divide any of this, but it can't divide this last thing left over, right? The moduloing by 10, so you'll see, this may seem scary, but there's kind of only 2 concepts we're going to use modulo for in this class. One, when we modulo by 10, because it's really useful to get the last digit, only the last digit of a number sometimes. The second time we'll use it is when we modulo by 2. And this is typically used to check if something is even or odd, right? 4 mod 2 gives me 0 because 4 divided by 2 has no remainder, right? Remember, all modulo does is give you the remainder. 101 mod 2, that's an odd number. So if I divide by 2, we all know that you can look at it and go, oh yeah, quotient's going to be 50. But the remainder is even easier to calculate because you know there's going to be a little bit left over because it's odd, and that little bit is 1. So they all have the same precedence. It just multiplication, division, they all have the same modulo, they all have the same precedence. So you do whatever you hit left to right, or left to right, since it's that perspective for you. Okay, and then finally, addition and subtraction, which you already know. I don't think I need to go over addition and subtraction. So exactly the same. The only thing I've really done is shown you two new operators, which is integer division, which just simply says give me the quotient, and modulo, which says give me the remainder. You will need to use modulo only for the last part for the fourth problem in Lab 2, and we will be going over how to use that in Thursday's lecture. Okay? So, now what kind of operations? So we can do operations with we can do operations with floating point numbers. We can do operations with our integers. The other one I mentioned was strings. Can we do any operations with those? So let's do hello. I'm going to just simply go S. I'm just going to simply say S is equal to hello, so I only have to type S, right? S is hello. S plus 1, right? So that gives me an error. Let's read the error. Trace back, which says, hey, let's look at what caused the error. It caused it in your shell. It caused it, and it was this that caused it. And then it's this last bit that tells you. It can only concatenate string to string, not int. String, not int, to string. Basically, it's saying, concatenate I'll get into in just a second, but basically it's saying it doesn't like strings don't like messing with numbers like that. Right? You can't, how would you even add 1 to hello? What's the appropriate way to do that? Java has an opinion, which is you convert it to a string and glue it together. Other programming languages follow that same one. Python wants to make sure that you really want to add things together before you do that. Specifically, the type of adding together we're doing, hello plus space world, like this. So notice that we've got hello here and plus space world. This is called concatenation, where if you add two strings together, it does the least surprising thing to it, the least surprising, right? Which is it just glues them together, right? Common trick question you'll see in most CS1 classes is something like this, which is 1, 2 plus 3, and note that they're strings. Common trick question in computer science classes, right? If you add 12 plus 3, that would be 15, but these are not 12 and 3. This is the string 1, 2, and the string 3, right? They're strings. So if you add together, you get 1, 2, 3, right? Because they're strings, it's text. It's much easier to see if I do AB plus C, right? Right? So you can glue those things together. What about AB minus C? That doesn't really make sense. Or sorry, AB. That is saying it doesn't recognize the variable C. That's because I forgot to cast it. Or sorry, I forgot to turn it into a string. Yeah. Okay. You know what? It would have just been quicker for me to do this. Right? It says you can't. There is no unsupported operand types for minus. You can't do string and strings for the minus operator. Same thing if you try to do. Same thing if we try to do over here. Multiply, right, or divide strings, right, doesn't work, or, right, because there's no least surprising operation to do for these things, right? There's nothing anything I would show you would be surprising, okay? And it wouldn't necessarily make a logical sense to do. There is one other operation we can do with strings, and it is actually unsurprising. You can't add a string to a number, but you can multiply it to a number. So ha times 5. Ha 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 ha, right? That's unsurprising, that if you multiply a string, it does what it calls replication, which is that, and this is Python exclusive. It's actually a very useful thing, where basically it will just simply multiply, you get a string, and it multiplies it out. It's very, very useful. Just repeats it a bunch of times. If I did, let's see, AB times let's see, so if I did BA plus NA times 2 gives me banana, right? Now, any 4-year-old will tell you, any like 4 or 5-year-old will tell you that the issue isn't spelling banana, but stopping spelling banana, right? Banana, no, 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 no. So, we've got here so that's basically it for strings. You can glue 2 strings together, or you can throw a number in there to repeat it, which is a niche case, but when you want to use it, it's really useful. So most of what you're going to be doing in this lab are problems like this one, okay? So let's go ahead and open it up, just to kind of show you. Because, again, your lab instructor should be doing the same thing, but I like being able to kind of show you here. So Messy Chocolate has multiple programs in it, and it is due next Wednesday. I'm going to be trying to make these due in the middle of the week. For the Monday labs, though, we might push these back a bit further, since you technically would have only 2 days between your lab instruction and the due date, so we might push those back a bit later for the Monday labs. The first one is to basically do plug and chug. That's what this is. And by the way, they're not in order of difficulty. So some of these are easier than the others. In fact, I think number 3 would be the easiest. So the Harris-Benedict equation is an old BMR equation. It asks whether a person's gender is male or female, and then gives you a separate equation whether or not you're male or female to figure out what your basal metabolic rate is. Your basal metabolic rate is basically the number of calories you burn just by existing, right? And it doesn't account for any movement you do, any effort. It's just literally the calories you burn just kind of naturally by being alive. It actually is the majority of the calories you use, okay? And there's a lot of different equations. This is one of the oldest for them. There's a lot of different equations. This is one of the oldest for them. If you're a woman, then this is, again, a very old equation. And man uses this old equation. Now, because we don't know how to do if statements yet, you don't need to ask for the user's gender. We haven't learned that yet, so you just simply print out the results of both the equations. But what is the result here? Well, I don't want to actually calculate the basal metabolic rate here. I mean, I do, but that's not what the answer is. If we read through the question, what it is, it says, here's 2 equations for the basal metabolic rate. A chocolate bar, your average chocolate bar is 214 calories. Write a program that calculates how many chocolate bars that you should consume to maintain that basal metabolic rate. So for instance, if the basal metabolic rate says, hey, you burn about 1,400 calories a day, that means you need 7 chocolate bars to survive. You do not have to be a health professional to know this is a terrible idea, but it's a fun one. Just simply print out the results of both of these, basically saying, so your answer should be like a number like 6 or 7, or maybe you can use a decimal point. I'm not a stickler if you say you need 7.5 chocolate bars or something like that. Okay, and please note that we are using American freedom units here, not metric units. So this one specifically works with pounds and inches. So here we need to use our, here we have messy code, which basically has a few errors in it, which you need to fix. This one is the easiest one, which is a classic one. It's a temperature converter. So here, write a program that converts a temperature from Celsius to Fahrenheit, right? It should prompt the user for an input, read a floating point value from the keyboard, and then calculate the result, okay? And in case you forgot, because I certainly have to look things up all the time, Fahrenheit is equal to Celsius times 9/5 plus 32, right? That's how you convert from Celsius to Fahrenheit. Okay, so don't we turn it around a bit, okay? So how would you do this program anyway? Well, let me go ahead and write a script, and we'll do it the other way around, shall we? Okay, and we'll do it the other way around. So we'll write a program that converts the temperature, instead of from Celsius to Fahrenheit, from Fahrenheit to Celsius. It should do 1, prompt the user for input, 2, reading a floating point value from the keyboard, and 3, calculate the result. So now, oddly enough, I like to do these out of order, but for you, we'll probably do these in order because that's what you're doing right now. So the first thing we need to do is ask the user to input something. So here, again, I'm not doing the problem, I'm doing the opposite of what your problem is asking to do. So input. So the first thing we need to do is use an input statement. This just simply gets something from the user's keyboard in response. So enter Fahrenheit temp, right? And I'm being a bit sparse with with what I'm doing here because I've got only half the screen to work with giant text. Temp. Or FT for Fahrenheit temp, sure. So input Fahrenheit temp. So the input statement, what it does is that print, not point, FT, right? If I run this, let me go ahead and call it Fahren. Okay, whatever. So over here, what the input statement is that it prints out whatever in the input statement, and then it waits for the user to enter something. In this case, I will put in 98.6, right? And right then, once I've got it over here, this separate line over here, print FT, prints it out, right? Make sense so far? We'll be doing a lot of this on Thursday, by the way. Okay? A lot of this on Thursday. Where we do an input, and then we print it. Okay? So we have the Fahrenheit temperature. We could even just call it, well, I'll get into that. And now we know the equation, by the way, is for Celsius was what? Celsius is equal to Fahrenheit times 9 divided by 2 plus 32, right? Right? If I recall correctly, or is it 5/9? See, even I forgot. No, it's 9/5. C is equal, oh, no, it's the other way around. F is equal to C. So we want to calculate, so now I've given you F, we want to calculate C. So I'll go ahead and do that annoying thing of balancing that equation. I always like to make sure, so over here, so we're going to do, so F minus 32, right? Going to go ahead and remove 32 from that side, right? Then we need to multiply both sides by 5/9, right? We have a 5 over 9. Sorry, we have a 9 over 5 on this side, and we want to get C by itself, right? So we can have an equation for just Celsius. So what we need to do is that we need to multiply both sides by the same value because again, remember with equations we balance. 5 divided by 9. Those would, right? Both of this would, and this of course, as you know, is 1. This is just a fancy way of turning this into 1, right? There's your algebra. That's why it's a prerequisite for the course. So, and if we do that to one side, we have to do it to the other side. So now the equation is balanced. So what we need to do is so now we can rewrite this as C is equal to F minus 32, those parentheses are important here, right, times, and then 5 divided by 9. Are the parentheses important there? Why not? Throw them in just to be sure. 5/9. The answer is it wouldn't matter whether or not they're there, but, if we're going to be grouping things together, it's useful. The nice thing about order of operations is that if you're making the equations, you can use the parentheses however you need to, just to make sure there's no ambiguity. Okay? So if I run this, of course, and I tell it to put in 98.6 and tell me what's that in Celsius, it's going to tell me error, F is not defined, right? I haven't created this variable yet, F. I'm trying to use an equation, I haven't created the variable. I did create FT. Can I use that? Okay, can I use the variable FT for Fahrenheit temp, right? Well, we get a different error then when I put in 98.6, which is, and if you're a Magic the Gathering player, you may find this phrase familiar. Reading the error explains the error. So good reference for the three of you in this class who play Magic the Gathering, I guess. So, unsported operand type, string and integer. This means that, right, you can't, this is a string, minus 32. Can't take a string and subtract it. Remember, we typed in something. Python doesn't know what we're typing in, right? I could have easily have just put in, let's see, sorry. I want, why is it not going? 9 degrees, like that, right? It doesn't know what I'm doing. So, what do we need to do? What we're going to do is that we're going to convert it. An operation you haven't learned yet, and I'm teaching you now. So I'll go back to calling this F. F is equal to float FT. We've got 3 operations like this, one for each type. We've got int, which says, given the thing in here, turn it into an integer. We've got float, which says, given the thing in here, turn it into a floating point number. And then we've got the last one, which is str, which is short for string, right? Remember what I said about programmers? We love to not have to type out stuff. This says, turn whatever I just wrote into a string. Thank you very much. So here, what we've got here is now a 4-line program. And with 5 lines, we'll be done. I swear I learned how to type, okay? Swear. Maybe it was only yesterday, but I learned how to type. So, print. C. Let's see. FT plus is plus C degrees Celsius. Let's go ahead and open this up so you can see it. And don't worry, I can drop this in Discord for everybody to see. Okay? And I'm missing a plus operation over here. All right, so let's go through this. So this is the full working program now, and I know I kind of just jumped from like nothing to just writing that out. A big thing. Okay? So I will tell you in just a second. But this is what our full working program should work like. 98.6 gives me 37 degrees Celsius, so it works. So first off, where were we? Well, we figured out this part first. It's fairly easy. Given an input, and this print statement we didn't need, it just simply confirmed what we were printing out, right? Sorry, what we were taking in as our input. Okay, so we didn't actually need that. I can comment it out. Remember what I mentioned in lecture 2, which was that this symbol, the hash symbol or the number sign or the pound sign, that's called a comment. That means the computer says, oh, that's human stuff. I'm not going to read it. So you can use that to turn off a line of code fairly easily. Okay? Or you can just delete it. So now, this next line, we take this and we convert it into a floating point number. Why floating point? Because 98.6, which is your standard human temperature in Fahrenheit, that's a floating point number, right, as opposed to an integer. We could just turn it into an integer, right? It would just give us something slightly less, let's see, oh, it just wouldn't like, it just would expect the whole number then, right? I can't take a double and then turn it in. And then I get less useful results because I can't put in 98.6. I can only put in 98, which is a substantial difference, as we'll see. Right? So that's why I use float here, because I know I'm taking in a floating point number. 98.6. Okay? And I believe I tell you in the problem definition, read a floating point number. Right? So then we use the equation that we figured out, right? Celsius is equal to Fahrenheit minus 32. What is F? We ask the user for it. So this is essentially just asking the computer to do the plug and chug operation for us, right? Just throw it into the equation and solve it for us. No math on our part required. Okay? And then over here is the print statement, which is, I can basically turn this over here. This might be a bit easier to see over here. So we say, turn this variable into a string, right? Because that's a number. Turn this variable into a string, and then glue it together with the word is, which is then glued together with the word, with the Celsius answer, and that's glued together with degrees Celsius. So remember, when we're doing, so you'll do a lot of print statements like this. There's nothing stopping you from have done this at first, and probably would have been better to start out with this. Print strc. Fingers, what are you doing today? 98.6. 37 degrees. In fact, if it's the only thing, I believe, in fact, if it's the only thing that you're printing out, print doesn't care what type it is, it will print it out. But when you have to glue stuff together, that's when you get into this situation over here. So this is a lot of your operations are going to be like this, asking the user for the inputs to an equation. Make sense? That's what you're doing this. So for problem 3, for the Fahrenheit to Celsius converter, that's what you're doing. For the BMR one, that's all you're doing. You're just doing it with 2 equations and printing out both the results. For this one, well, here you're going to be using multiple equations kind of back to back. Here what you're going to want to, or you can use one equation and you just kind of have to solve it. It's annoying. But you'll notice my hint here, use the modulo operator. We'll be talking about how to convert time units on Thursday though, so that will be good. Now, let's go ahead and take a look at something else and have a bit more fun, okay? So now this entire interface, to be honest, is a little bit boring, especially when you're first learning. So enter turtles. So if you want to get here, just go to our Canvas site. This is the link I pulled up in the beginning, where we go to Module 2 Overview. And over here, and it says Tuesday will be a Q&A review session with a short exercise. And this ended up being more of a lecture than a review session, but hey, I just haven't updated the text. So this one is driving the turtle. This is exercise 2 in your textbook, or sorry, project 2 in your textbook, and it's a good one. So if you don't mind, take a second to pull it up, because this is a graded in-class exercise. If you don't do it today, that's fine. Again, these in-class exercises, as long as they get turned in by the end of the semester, I'm a happy man. Why? Because some people miss classes, and sometimes it's because you're sick. So I want you to be able to catch up if you're sick. Yes?
So I'm in the table of contents for textbook.
Scroll all the way down to the project list. It's like it will go appendix, and then it will have a list of projects. You see it? Project 2, yeah. We're going to end up doing a lot of these. So so one of the things I love about Python from a pedagogical standpoint is that it's got turtles built in. Now, turtles was a paradigm I think it made for the programming language Logos in like the 60s or 70s for teaching kids how to code. And it honestly does a great job of it. as far as graphics are concerned, it's not that great or not that powerful. It's very good at certain things like drawing spirographs, right? Those little stencil things that you can make weird geometric pattern shapes. Really good at doing those kind of things. And the culmination of like our basically of our homework, module 7, where basically you can kind of show your parents or your roommate, hey, look, I can code, will be a graphical hurricane tracker using Turtle. It's pretty nifty. But we need to start out somewhere. So Turtle is pretty nifty. And we've already got this box over here with some code loaded into it. And we can save it and run it, and it does this. So I'm going to go through this, right? It did this. So let me minimize it so you can see it in action. Save and run. So you notice that it animates. It's not just, it doesn't do it all at once. It actually does it. Okay? So let's go ahead and look at this. So we have so for this one, for turtles, unlike Java, Java has like a lot of magic words that you have to know. To know Java program, you have to do public stat. I think I've already gone over that. Yeah, I went over that a couple days ago. You have to do a bunch of magic words that you don't know the meaning for any of them are until like 2/3 of the way through the semester. Here we only have 2 magic lines that you have to know, and that's it. First is import turtle, and all that does is simply say is load up the turtle module. What this is that there's a bunch of already written Python programs that are and special Python programs called libraries that come with Python, and it would make programs super slow if you loaded up all of them. So you only include the ones like the math operations you need, and if you need like to do servers, you include HTTP server. Or if you need turtles, you say import turtle. So you just use them as needed. That's line 1. That's super simple. Line 2 is blank, just for simply organization's sake. Line 3 is the other magic line, which creates a turtle object. So this is the only thing you need to know, just because it's repetitive. So remember, the thing on the right gets stored in the variable on the left. So the variable on the left is called myTurtle, and whatever this is getting stored in it. And what this is, turtle.turtle, says there's this thing called turtle from the turtle package over here. See that? And that creates a new turtle object. What in the world is an object? We'll get into that, but basically it's a thing you can use, like an integer or a floating point number. And then that's it. So now that we've got that, we can do things. For here, we've got myTurtle.color. Green. Fairly self-explanatory. If you didn't have that line, by the way, by default, it'd be black. And it understands a lot of predefined colors, by the way. Like red. No problem there. MyTurtle.forward50 tells it to draw a line of length 50. Okay? 50 pixels to be precise. So, forward 50. MyTurtle.up, lift up the tail? All right, so let me explain the entire turtle paradigm for you. We've got this giant piece of canvas paper here, and you see that little arrow? That's our turtle. Turtles, and this entire paradigm is super dirt simple. The turtle starts at coordinate 0, 0, and he's got a paintbrush attached to his tail. And as he walks, he drags the paintbrush along the giant piece of paper. And you're looking at that from the top down. That's it. So when he say move forward 50, he moves forward 50. And then when we tell him to move, and then here, we've got a gap here because we tell him to move 50, lift up his tail, and move forward. And then it says to move forward another 50 without drawing. Right? Move forward 50, lift up your tail, move forward 50. That's what he did. So now he'd be over here. Next line. MyTurtle.right tells the turtle to change the direction to the right. So here, right 90. This means just turn 90 degrees. Turn the turtle 90 degrees. Make sense? Turn 90 degrees to the right. So now he's basically facing south or down. And then we tell my turtle.down to put him right up, lifts up the tail, down, puts down the tail. And then my turtle.backwards is equal to 100. Boop, just like that. And so he draws that, and he moves backwards. So you've got forward, back. So to move the turtle, you do forward, backwards, and you've got left and right. And that's it. Now, labs 3, 4, 5, and 7 all use turtle. The reason we do this is because it's super easy to kind of see loops and how they work with turtles. It's very nice and satisfying to draw stuff. Okay? Right? Forward, backwards, left, right, up, and down in color. There's a bunch of others you can look up by just typing Python turtle. But the goal here is, for the next 10 or so minutes, is to play around with this. And you just need these two lines. Import turtle, which is already there, and then to create a turtle. You can think of the variable as a name tag. I often like to do this. Bob is equal to turtle.turtle as opposed to my turtle. Right? Why? Because my turtle is, that's a pain to type, right? Whereas Bob, no, that's B-O-B. Great, I'm already done. So if I do something like B-O-B and then I can change his color to something, like, again, green. And then save and run, and we can see him over here. He's just in the center. By default, he's facing to, and by default, the turtle starts in 0, 0, and is facing in the positive X direction, right? He's facing to the right. He's facing, I guess if you're seeing him, he's facing this way. Okay. So go ahead and play with it for a bit. There's a lot of, you can even look up example turtle programs and paste them in from the internet. It's a lot of fun. Turtles are great for doing, again, those kind of spirograph things. Like, so go ahead and take a minute, and then, and then I can show you some other ones that we'll do later. But again, this is just kind of giving you a kind of preview of what we'll be doing in week 3. Yeah. We are actually at the end of the class today, so if you do have questions, I'd be about any of the programs you're writing, I'm going to be sticking around. My train doesn't leave till 4, so I've got plenty of time. All right, take care.